All right, we are good to go for class number 5 in the UBC Ecosystem Modeling course, FISH 501. And today we have a guest lecture by Deng Palomares from UBC, and who's working on FishBase and SeaLifeBase, and I'll get back to that in a few minutes. But let me just start by acknowledging that we at UBC are on the Coast Salish territory, and that means that we are more specifically at the ancestral, traditional and unceded territories of the Musqueam, Squamish and Tsleil-Waututh people, and we acknowledge that. So let us turn to the presentation for today. It's by Deng Palomares, and Deng has been working on FishBase and SeaLifeBase. He's the lead developer of SeaLifeBase and one of the original key people involved in development of FishBase. So we're very fortunate actually to have Deng talk to us about how we can get data from FishBase and from SeaLifeBase for use in ecosystem modeling. And I've had the pleasure of working with Deng since we were together in the Philippines in the 90s. And over the years, we've been working together on how you create bridges between FishBase, SeaLifeBase, and EWE, and that has developed quite a bit. And there's even more to come on that front, so we look forward to those future developments. But with this, let me welcome Deng.
So, good morning, everybody. Today I'm going to talk to you about FishBase and SeaLifeBase. As was really mentioned, I've been in FishBase since the beginning and one of the developers of SeaLifeBase. In this lecture, we will first have an introduction about FishBase and SeaLifeBase. We just call it FB and SLB, it's easier. And then we will go through getting information by first knowing your fish and knowing what kind of information you will get for this fish. So whether it's for a species or a population, and then we will look for a list of species, using the search tools in FishBase and SeaLifeBase, and getting into the life history for parameters that are used in Ecopath modeling, and then a little bit about downloading data and how to cite FishBase and SeaLifeBase information. So it all started with Daniel with a box of cards that he wanted to use to make an encyclopedia of fish. And the creation of FishBase happened in 1989 when Daniel met with Reiner, and the two of them had this bright idea about creating a database out of this box of records, individual fish records that Daniel had. And that's 1989, that's when the story of FishBase started. FishBase was developed at the then known ICLARM was the name of the institution. It was an international research institution, International Center for Living Aquatic Resources Management, which is now called World Fish. And when it was launched in 1990, Reiner was the project leader. And quickly FishBase became the world expert on fishes, and it provides the expertise to the world. It provides data to the Catalogue of Life and the World Register of Marine Species. SeaLifeBase, on the other hand, was developed as a project of, again, the sea around us and FishBase, because in the early 90s, there was a clamor for FishBase users in that time for us to create an at first it was clam base, so people wanted us to create a mollusk base, and the idea was only followed through in 2005 2005, I think it was, when Nicola and Diamond made a successful pitch to the OUT Foundation to create SeaLifeBase. And SeaLifeBase was launched in 2006. I was project leader and I created it using the same, exactly the same structure as FishBase. And with a younger team of encoders in the Philippines. FishBase and SeaLifeBase both sit in the Philippines with Philippine staff members. FishBase is has a lot of connections, say, so it has a wide network. There are at least 700,000 unique users per month, and there are at least 2,500 collaborators throughout the world. But the most important thing is that FishBase is how to say that it gets most information, not most, but it gets new species that are being reported in the catalog of fishes. So what FishBase does is it's getting everything that it can from the catalog of fish to improve the taxonomy of fish. And there is a connection with OBIS and the Global Biodiversity Information Facility, because FishBase encodes occurrence records that are sent, occurrence records that are vetted and sent to OBIS. It is also one of the maintaining projects of Aquamaps. So all of the records from FishBase go to Aquamaps. FishBase is the world expert on fish, as I have already mentioned, for the World Register of Marine Species, and provided data to the Encyclopedia of Life a while ago. There is direct communication with museums and individual scientists, of course, and of course, internet sources. The SeaLifeBase is younger and has less of that, but it follows the same structure. So SeaLifeBase uses OBIS for getting country information, making sure that a species is assigned to the right country. And SeaLifeBase is also one of the maintaining databases for Aquamaps. And SeaLifeBase works with worms. So there's a tripartite memorandum of agreement with worms between SeaLifeBase, FishBase, and between SeaLifeBase and FishBase and worms. SeaLifeBase uses worms as its taxonomic backbone, but SeaLifeBase also gives to worms the traits data that it has. Right? We only use published information, and it can come from monographs and FAO, as you see there, FAO things or books, but it also can come from peer-reviewed information, like from journals. It has an open data policy. Both FishBase and SeaLifeBase has an open data policy, and we provide that data via the internet. We do not, however, provide or maintain raw or private data from other databases. And this is the breadth of the contents of FishBase and SeaLifeBase. You can see that the first thing that we would have would be taxonomy, of course, which is over here. First thing we have taxonomy, distribution, and the traits data that we would have would be concerning population dynamics, trophic ecology. That's where we are big at, and reproduction and life history. There are hidden, say, components of both FishBase and SeaLifeBase that are not made available publicly, but are in the databases. Okay. Now, what we need to know is how, when of course FishBase and SeaLifeBase are made for getting to know more about a fish for any species. Species is the hook of any information that you have in FishBase and SeaLifeBase. So the smallest unit of taxonomy is the species. when we are saying know your fish or your invertebrate, the first thing is that there are lots of synonyms. One fish might be called many scientific names um, from the time it was discovered and the first time it was described up to now. And so there is the taxonomists themselves, they have um, an agreement to say, okay, we need to have a valid name or an accepted name. So if those of you who have used the worms before, you would know that this is something that is or any species database that's out there, um, you would see there's always something called accepted name, and both FishBase and SeaLifeBase have that. Now, if you have a list of species, for example, and you wanted to see what is the accepted or valid name of those species, you can actually use a tool. We call it the match names tool in both FishBase and SeaLifeBase, and you will be able to actually find out if the names that had been published or that are available from a certain list are accepted. How do we do that? So I'm just showing you here a sample list of 4 names. They might be fish, they might be not fish. And there is a match names tool in FishBase, and you can find that under tools. So in the search page, if you scroll down to the tools section, you will see this match names radio button. And when you click that, you get this page, and you just stick in your names list there and submit. And if you were in FishBase, you would get a return of that using here. So of my 4 names, there's one that is not in FishBase. Why would that be? So say, let's try that in SeaLifeBase, and now I know because it's an octopus. So it's very easy actually to get this back. It's like a few seconds. So if you had a longer list of names, then maybe it will take you a little bit more time. But so when you get that results of the matching names, it provides you with a valid name, which is here. And this valid name column provides you a linked scientific name. It's a linked scientific name to the species page. So it will provide you a way of easily going to the species page right away. And with that, it also gives you the author of that scientific name. So this scientific name was used in Linnaeus 1758 the first time. If there is a parenthesis, it means that it was not the first scientific name that was assigned as the valid name. So this is a second use of Oreocornis nauticus as its valid name. And then it will give you family and order and class. And very importantly, it will give you the code that is used inside FishBase to get to all of the information that is associated with that species valid name. The same is true for FishBase because it's the same format.
Deng, can I ask, does this work only with scientific names or also with common names, the match?
The common names would always be associated with the spec code.
So can you search for match names?
No.
In this match routine?
No, it only uses scientific names in the match routines. But in the search page, if you searched for any how do you say that, common name combination, and you say contains this combination, it will provide you with a list of possible scientific names. But on the bulk side, we don't have that. Maybe we should, but yeah, thank you, Lily. That's an idea. we should think about that in the future. But if you had a list of common names and you wanted to know about, what could be the scientific names, you can either use our FishBase or you can send it to me and we will find out. So I was saying earlier that it provides you a link to the species summary page. So this is just a species summary page. I'm going to show you species summary, the contents of the species summary page. So the first thing is that you have the valid name here, and you have the FishBase English name that we use mostly. So the FishBase English names are mostly based on the FAO official name or the AFS, that's American Fisheries Society trade names. Or if in a country, for example, Australia, that speaks English, well, where English is the official language, and if the species only occurs in Australia, then we use the Australian name because Australia is an English-speaking country. So for English-speaking countries where the species is only known in that country, we use their primary common name or English name. You see here, this is the map from Aquamaps. I don't know if this is still done really, but you can have the shape files from Aquamaps downloaded and used in the but that is not done here. That is done in Aquamaps. So if you clicked on this, you will be taken to Aquamaps, or you can just go to Aquamaps via the link. We have the pictures. Actually, this is the picture that was chosen by unanimous decision. But there are lots of other pictures. So if you went to the pictures or videos, you can see other pictures that are either submitted by photographers who are collaborators of FishBase and who actually know how to vet the classification of or the identification of that species in the photo. And then there are things like sounds and stamps and Google Images, but you can explore that later. The next actually thing that we have to put in our minds is that in the species summary page, there are species-specific information and there are population-specific information, and they are a mixed bunch. But of course, the taxonomy is species related, and that's species specific, and that only involves anything that is about the species. The environment of the species is not a population trait, it is a species trait, but the depth is a population trait. So that's why it's in a range, right? So you have 0 to 600 meters. And then the distribution is also, of course, this is defining the populations of that species worldwide. The other thing that I wanted to mention is that, again, because we only use published information, so we can refer to the reference where we found that information from, or where this information was based on. And there are, I think now, running to 15,000 references that are used in FishBase and still growing. And I don't remember the numbers in SeaLifeBase, but it's more than that. Now, this is the second part of it. You have the length at first maturity, size, weight, age. That is a species, a specific information. Maximum length is a species specific information. And then you have the short description, Now, I did not say that this is a population-related information, but it could be because you will have different numbers, or say, for example, soft rays and all of these morphological traits would differ depending on where you find the fish. So that would be a population-specific information. And biology, of course, is mostly population-specific. The life cycle, mating behavior, also mostly population-related. And then towards the bottom of that, you will have the main reference. So the main reference is the reference where that the most, how do you say that? So that's the identification of the species and the description of the species and the first records of where the species were found. And that is usually an FAO species catalog or a monograph or a faunal book. So that would be the first reference that we use to identify that species and to make the species record. Then we also have the IUCN Red List, and this is most of the time, how do you say that, updated. So we do, with the ICs and the IUCN, we do regular updates when a new update from either one of those come out. We have threats to humans, and this is also based on a huge monograph of the, how do you say, poisons and so many things, marine animals, the threats to humans, which is actually species related. This is a species specific information. Human uses, this is all based on FAO categories. And then we have a suite of other information that most of which are population specific or related, but some of which are species specific. For example, ecology, larvae, and swim type. When it's blue, it means that there is something in it. So it is an active link. And the bluer your more information section is, the more there is in FishBase, the more information we have in FishBase. Under that more information section, you have tools, where you have an important thing that will be used later is the life history tool. And I go back to that later. And then all other information sources that is associated with that species. And then at the very end, and this is, I think, the most important part where many users would like to point to, is estimates based on models. So this section is based on models. You will see the references of the model that was the basis of these estimations. And of course, using the information that we have in FishBase and SeaLifeBase on these models, we can predict, for example, the Bayesian length rate relationship, which is here, which is very useful for Ecopath modeling, and it gives you the information that it's based on. For example, a look at trophic level. So it gives you 4.1, and this is based on diet studies, which is the preferred, we'll talk about that later, which is the preferred information for trophic level, and so on. So this provides, say, pre-programmed routines that comes out with estimates that can be used in models that people are doing. So I think that's just to summarize. So in FishBase, we have species related and population related information under this big, say, sections that you have in that species summary page. And so scientific name for species related information, environment distribution, biological traits are all specific to the species, whereas common names, life history, food and feeding, reproduction, and abundance are all related to different populations of that species. And most of the time, this is what you will be using for building your Ecopath models. That's the population-related information. Right. So we had this list of let's say, names. I'm not going to say these are a list of species, but these are a list of names. So for the sake of showing you how to do this, right, it's very simple. You open your file, you open FishBase, and you go to under tools, right? So this was the search page. I just scrolled down, tools and match names here. And then there is this window that is now you're going to use to paste whatever you copy from here. And you copy that there. And then go back, copy the next one. And then copy it there. Let's just Control C, Control V, and I submit. And that already gives you everything that is known in FishBase, and these are the names, right? There is one important thing that you have to notice is you have this yellow highlighted name here. Teragra chalcogramma is not anymore called Teragra chalcogramma as its accepted name, and the accepted name is now Gadus chalcogrammus. So you have to use that name from now on. And if you wanted to now use this, yeah, you copy it because this is what you now know. Simple Control C, highlight copy. And if you had your Excel file open, you just right click and paste. And you have that there already. So what is important here is that you have your valid name, which is you're going after, the taxonomy from family to class, and again, the spec code, and that you have to keep. Now, having done that, you have established that these are not matching. What I do, I just copy it again, copy that, and I open, I go there. I open SeaLifeBase. I do the same thing. I go to match names and then Control paste. Sorry. You see, that's why I couldn't just copy and Control paste because of those numbers. So what I would do is use this so I can just copy without the numbers. That's why I did that. Right? And then V, submit. And then I would have then now established, well, now I've found which ones of those are species names, and all the unmatched here are not species. So you have Sebastus is a Sebastus haliotis, Isurus, these are all genera. And then Rajiformes is a fish class. And then you have Bivalvia. And of course you have this, which are not really scientific names. There you go. And then you can do this again. And if you needed it, right, you can just copy it beside the fish. And these are the non-fishes. And then you can go back to your, how do I take this out? I don't know how to do this. So you can go back to your fish names. And then if you wanted to look at what you have for a fish, what kind of information you have for a fish, you can go to, doesn't have it. Let's look for this. And it should show you the species. Where is it going? It's not going in right there. So this shows you the species. For this species, you can see that we have a depth range 0 to 250 meters. That's a trait that you might be using in Ecopath. So you have to look for other traits that you might need. Maximum length, for example, would be a trait that you would be using in Ecopath. The environment, right? So that's something that you need in Ecopath. The life cycle, mating behavior, but more so here, what you need in Ecopath is diet, right? It doesn't have growth though, but something that you need is mortality, which is not there because mortality is under growth. And so this is what I was looking for, is for you to identify what kind of information you have for that species. So all you need to do is go back to, I don't see it there. Yeah, so I shouldn't have done that, because if I go back, I would have lost my, my list. So the thing to do is to right click and then open in a new tab. And there you get to go back to your names, right? That's a trick. So there you go. That's the only thing that we would like to know, is how much information there is for that. That would be usable for you in doing your Ecopath models. Price category is data that is provided to us by Rashid's group, and that category is, it's all that we have. So I don't know how Rashid and his group actually are deciding on the category. So I would think that there is, yes, I remember. So anything that is below 1,000 is low. Anything between 1,000 and 5,000 by ton. Sorry, this is priced by ton. I think it was 1,000 and 5,000. I have to remember what the categories are. Is medium, and then anything higher than that is it. Under here, estimates based on models. Yes, of course. For example, we use resilience in assessments, in fisheries assessments. Resilience is it's a prior for some of the models that we use for fisheries assessment. Trophic level is important information that is necessary for the estimation of marine trophic index for an EEZ, and that is used by the sea around us, of course. Length rate relationships is used by another project called the BROOVS project. BROOVS is the baited underwater research vessel, research videos. BRUV, yeah, research, baited, remote, sorry, baited remote underwater videos. And what happens is that they have a measure of the length from the videos. So they would measure the length, they would have an indication of the length, and they use the length-weight relationship for an identified species to identify what is the weight of that group of fish. So they would measure the length. There are tools for stopping the video in a frame that has fish, and they multiply the weight that is obtained from length-rate relationship by the number of fish that is in that video. So it's a very practical use for length-rate relationships. But there is also providing it. You can also use length-rate relationships for growth parameter estimations if you wanted weight infinity system models. So for ecosystem models, we need to know the geography, right? So what is it? Where we have to say which ecosystem it is. So for example, let's say the Salish Sea. This is the nearest Salish Sea that we have here. And then we have to define the functional groups. But how do we start defining the functional groups of the Salish Sea? So first we have to think of habitat. Is it a pelagic or demersal species? Is it marine or estuarine? Do you want to look at inshore or offshore communities? So let's say we want the whole Salish Sea, that means Salish Sea marine, and we want all of the functional groups inside the Salish Sea. Now, of those groups, we now have to define the components of the food web. So what are the components of the food web? So you start with the primary producers. Those feeding on the primary producers are primary consumers. Then you have secondary, tertiary, and top predators of your food chain. Now, then you have to ask yourself, are some life stages important of those functional groups, of those components? Are some life stages important? For example, the salmon has a life stage, right? The spawners go back and they move from the sea to up back the river, and then you have the juveniles coming back down to, and this is a migration that takes biomass out of the Salish Sea. So it's things like this that will affect the biomass composition of the components. And if there's a specific effect, then you have to actually separate the life stanzas or the life cycles, the life stages into life stanzas as separate groups, separate components. You have to identify those. And then there are the parameters of the Ecopath model that you can get from FishBase and SeaLifeBase. So biomass, of course, is not, but if you have, say, an estimate coming from length-based methods, then you can turn the length into biomass by using length-rate relationships. And then there's the turnover rate, which is production over biomass. And production over biomass is available as natural mortality. Then there's food consumption per unit biomass, which is available in the life history tool, and diet composition and trophic level, which we show are available in our species summary page. So establishing components of the ecosystem. First, geography. How do we do that? So we have tools. In the search page, we have information by ecosystem. For example, the Salish Sea is a listed, it's a known ecosystem, and you can find it in information by ecosystem. So depending on whether you have an established ecosystem, marine ecoregion, or large marine ecosystem, you will find that under the information by ecosystem. Otherwise, you have, if you are looking for, say, Eastern Canada, well, that's a country with a province or a part that is an FAO area. So that is Canada in the Western Atlantic. Is it north? What is it? What is the FAO area of Canada East? I forget. So you use the country and the FAO pairing. Sorry, yes, FAO 21. So you use the country and the FAO area to identify your geography. I'll show you that in a while. Now, once you have identified your geography, all you need to do is get there. And then under the information by ecosystem or country, or information by country, what you call it, sections, you will see that there are tools. There are 3 tools that respond to Ecopath parameters, or establishing the Ecopath parameters, right? But you start with the Ecopath parameters here, and this will give you already, look at this, your pelagic oceanic, whether something is pelagic oceanic or demersal, whatever. So it gives you an idea of the position of that species within the water column. And then it gives you the length, the maximum length. Oops. Yeah, I should have done this. Yeah. So it gives you affinity to substrate, and then the depth range as well here. And it also tells you whether we have information on growth, length, weight, Q over B, diet, and predator. So for that particular top predator, oh, I keep doing that. For that particular top predator, you have most of the information that might serve you in providing the Ecopath parameters that you need for that particular group of species. So that's pelagic oceanic, large. There is, I don't know, Billy, do you have the functional groups identified somewhere for Ecopath?
It's
Because
not in any way built in, but for many models we are using these functional groups. For instance, for our global model that we'll be talking about later, we're using these functional groups, and then we can link in through them. But it's not in any way built in as a fixed, defined part of the structure in Ecopath. It's just common practice.
Okay, so we in the sea around us, we have about 26 functional groups, or we have identified 26 functional groups using less than 30 centimeters as small, between 30 and 90 as between 30 and 90 as I don't see the chat. Between 30 and 90 as medium, and above 90 as large. So, and we use the FishBase functional groups here. So whether it's pelagic or demersal, bathydemersal, benthopelagic as part of that distinction of functional groups. So that's one thing that you already have a picture of what lives in this ecosystem and how to group them by functional groups. Remember that in FishBase you can always copy and paste. So that table, all you need is copy. So you can just copy up the trough here, and yeah, so you just copy and paste onto your Excel file. Then the other thing is the species ecology matrix. Now that's a nice one because it takes you to the life history tool. So there's, for each of those species, there's a link to the life history tool. It also tells you whether that species is native to that region or that ecosystem. And then it provides you all of the information that you need right away. So copy paste again is it will be very useful for this. Some of the species that are reported in FishBase would have been introduced, or would be strays, or would be most likely would be how to say that, misidentification, or maybe questionable. So you only use everything that's native. Right. Okay. Now, when you click on the life history tool here, it takes you to the life history page, life history tool page. And here I will start just providing you with what is in the life history tool. So there is, remember we had said that B over B, P over B is equivalent to mortality, and that's what FishBase can give you. And that's in this top section, and this is what we call the growth section. So you can, natural mortality is a function of L infinity and K, and that N of temperature. And this was based on an equation that Daniel published in 1984, and that Reiner modified in, I don't remember when, but yes, but more recently. And this is based on all of the growth data. So there's a link to the growth and mortality data here. Now, this is for all of the information in FishBase for that species. It does not mean that this is for your Salish Sea. So this is the sort of like the warning that you have to always keep remembering, is that if you have growth and mortality data, here, what you need to do is go into that and pick the L infinity, K, and T naught information that you will need for your information. I'll go through that with you later. So other things that you find there are lifespan and age at first maturity. This will help you if you were length at first maturity. This will help you if you were looking at life stanzas. Next part of the life history tool is length rate relationships, and which would be something that you would need if you wanted to, if you had information in length and you wanted to put them in as weight data. And then, so you have all of this other additional information that you might use or not, depending on whether you're looking at something that is exploited or not. So you can have an estimate of length of first capture, and then get ZF and E, exploitation rate. Then you have the other part of the Ecopath model that you would like to have is food consumption per unit biomass, which is estimated here. This was actually my thesis, and that equation was taken up in Ecopath, I believe, if it's still there. Billy, my equation is still in Ecopath? Or not anymore?
No, I think we go to FishBase to get it. So we're using it. And
You're
many
using
people
it.
are using it. Yeah.
But
it's
the
not
one
built
that
in.
It's not built in. So
No.
so this is available. So this is FishBase uses my equation, and sometimes you will have it properly because I had it estimated for that species, and sometimes it will just give you the way of estimating it. So the life history tool will give you a way of estimating it if it's not been estimated prior to that. And then it gives you all of the diet. So if there is diet composition data, it gives you the diet there, the link, so you can get to the diet data. And so the life history tool is very, how do I stop the, I'm just gonna stop share because I want to show you the thing live. I have, this is Sardinops sagas. Maybe I look for something else. I like using Gadus Marua because it has lots of data. So I can show you the cod. Right. So if you, for the cod, for something that has lots of data, so the cod is the most, say, studied fish in FishBase. It has the most information. So I go to the life history tool, and here you have growth data, right? So say we are looking for the Salish Sea, and I would like to know which ones are in the Salish Sea. So you can go for, so that's Canada. Let's say we have looking at the Canadian border.
We're going to have one
I don't know
problem.
which one
Then
is.
we don't have Gadus Morhua here. We have a Pacific cod.
Ah, sorry, that's right. Okay, so let's go to Gadus macrocephalus. That's why there was none.
Yeah.
Right, macrocephalus. Right, so
That's better.
that's better. Yeah, so we do have growth, right? So I just go to the life history tool because it takes me to everywhere. Remember the right click here so you can go back to this page later.
Oh, problem.
Growth parameters for macrocephalus. There you are. So this is all. So there's one for, that is the nearest that we have is the Hecate Strait. So we can use that. And they are not questionable, so that's good. They are not questionable, so they are vetted. So we can say, okay, let's do that. And we have one estimate of natural mortality here. That's 0.91. So this is what we want. So we have to use that. L infinity 94 and K of 0.270 for a theta prime of 3.38. Now, go back to macrocephalus there. I'm just going to here. Right. So if we, I've forgotten already. What was it? 3.38 and 94. 3.38 and 94, which is exactly what we have there. So we are okay. And well, that is the estimate of natural mortality, but actually we don't need that because we have it here.
We have 0.91 is likely to be way too high for this species in this cold water.
Okay.
So 0.3 sounds much more reasonable to
All
me
right.
than
So
0.91
is not.
If I was to use this, I would go in, I would look where does that estimate come from, because it really looks, but we don't need to do that here. But
so M doubtful, yes. Sorry, yeah. So what if you have that kind of information? It tells M doubtful. It says yes. So
it's too high.
That's too high. So this means that we are going to use. We know that that's 94, 3.38, and that's applicable to the Hecate Strait. And we use this 0.3 natural mortality. So there, we have that already. And then if we wanted to look at diet composition, it's here. So we do not have a specific Q over B. So food consumption per unit biomass was obtained using daily rations and the diel feeding of fish. So when I did that model, there was no specific information for Gadus macrocephalus. However, the equation that we are using provides a sort of like rough figure of food consumption per unit biomass, and using the aspect ratio of the caudal fin, and that aspect ratio has been generalized for fork-tail, big, large, like tuna. This is fork-tail, small pelagics, and they have this kind of tail. I forget the name. Lunate, marginate, lunate, and that's a shark tail. So we have the average aspect ratio for this kind of tail, which is this number, and then you have to say, you have to know what is the main food of that species, and this is main food is mainly animals, so this is a carnivore, and the temperature, the average environmental temperature where that species is found. And then you can change this, of course, to W infinity if you know what the W infinity is. But actually, this W infinity is based on our L infinity, 94, and on the average length rate relationship that is found for this species, which is there. You can also change this to be more specific to your area. But what is displayed here is the result of this. So it's the result of the Bayesian estimate that Reiner and colleagues installed in FishBase. You see the scoring here. If you have 0, that means it's not even used because it might be questionable. So you have lots of those things, what you call them, controls or quality control that is installed in FishBase. So users will not be led to using things that are questionable. However, we still have to mention that they are questionable so that there is no perpetration of that information anymore in the future. Right. So it comes from this. Of course, we can see the nearest that we have here is North Bridget, which is the USA, and it has an R-square, which is very good. So we can actually use that, 2.89 and 0.2240. Let's use that, 2.89. Where is it? Okay. Ha. So, where is it? I forgot the 2.89, 0.22, 0.2240. 0.0224, and then 2.89.
I think there was a 0 more.
There was another one. 40.
No, you're right.
Yeah. So recalculate. There you go. So it recalculated. It is now this. That should have been fixed there already. So that is your new Q over B.
Now, then, just by means of introduction to the equation down there, if we get for a second that we are looking at cod and just with these parameters, what would the impact be if we changed the tail type? So if we, for instance, try to make it a tuna type instead, what happens to that number over there? Just to give an idea about it.
All right. So tuna is moving constantly. Your metabolism is high because it's always feeding. Tuna is always feeding, so it always needs something as it moves. Whereas the lunate, the marginate type is basically a cruiser, and it's calmer, so it doesn't need to eat a lot more. So that's why you have a 1.6 body weight. It eats 1.6 times of its body weight per year. Whereas the tuna, let's just say this is a tuna, I'm going to be scared.
Oh, now it's 4.2.
Yeah. Now it's 4.2. So there's a huge...
3 times as much. Okay, let's go back to cod and then
Let's
see
go
what
back
if the
to
cod was not a carnivore, but something else.
What if the cod was an herbivore? Let's do this, right? So
Much higher
you can
again.
see that herbivores are eating more because they need more. They need more nutrients from, they need more to get the nutrients they need to grow. If it was an omnivore, it's
Which it is as when
between
it's younger, it's an
herbivore and
omnivore.
carnivore. Yeah.
Yeah, the younger stages. Okay, next thing would be if you go back to carnivore, so 1.6 again. What if the water was much warmer?
Yeah. So what is the
let's take 10 degrees.
Yeah, so much warmer. Let's say 15 degrees.
15.
So it's increasing again because the metabolism of fish is faster in warmer waters.
What if it's a small fish?
What if it's a small fish? Okay.
Yeah.
Now how do you change it? We make this maybe 50. Let's make it 30. That's a small fish. And then we recalculate. So you see here, and when it was 94, we had, I forgot the K. What was the K when it was 94? That's 0.27. So K
so that's
is
the growth parameter from that Atlantic growth parameter. Higher means it grows faster.
Yeah. So let's go, if it was a 30 centimeter individual. Ooh. So this is growing faster at 2.67 units per year, right? Provided that this pi prime is correct. So your natural mortality also increases. Sorry.
QB?
I have to say here.
Let's go down to, let's see what it is on QB.
And your QB is 5.2 times. Your W infinity is smaller, of course. Yeah, but 5 becomes 5.2 times. If this was a herbivore with the same marginate tail, it becomes 7.9 times the body weight. So you can see how each of those parameters change. And so you should not make a mistake for those parameters. Is that everything that you wanted to show you, Billy?
That's fine, yeah. I think it illustrates pretty nicely how it works with the tail story.
Yeah. What if it was this? Oof. So a small tuna is actually eating 14 times much of its body weight as a carnivore.
That's a macro.
It's a mackerel, yeah. Yeah, so, I mean, this is for groupers. These are, what do you call that movement?
Ambush feeders?
Burst feeders, yeah. So that's for burst feeders. Yeah, so there you go. So this is, you have to play with the life history thing, but you always have to know that each of those parameters are based on established empirical relationships, and that is about this page. If you go there, take you to all of the estimates that were used. We still haven't found a way to diacritical marks to fix the diacritical marks. But
the life history table, the life history table is really important. I would say I spend most of my time in FishBase on that page.
Yes, me too. This is the tool that we use to establish everything. And if you want to read more about where the relationships are, you have to understand and read this page. It's really, really important for you. And all the references that are used are here. So yes, right. So that's the life history page, and this is the most important. Where is it? Ah, yeah. Thing that you will need when you are using Ecopath. So the next thing is just to give you an idea of what we have in FishBase. So you have feeding records by species in FishBase. You have those numbers, and this is number of species with information. Okay, and those numbers for SeaLifeBase. SeaLifeBase is still growing, and one of the main say effort that we're doing is diet composition, food items, and predators. So the trophic ecology is our main focus in SeaLifeBase to make that available. So I am going through this set of slides because I would like you to understand that it's not just, we had to build a structure around the food items. So the food items can be an algae, can be a copepod, it can be a fish, or it can even be a turtle, and all of this. And you cannot just name them because they have different trophic levels, basically. So we had to provide a hierarchy for food items. And this is the hierarchy of food items that we have established so that we can use the database structure to group food items and provide for each food item a baseline trophic level, because that baseline trophic level is important in estimating the trophic level of the species that eat that consume those prey. So we have the food item one, which is the wider group of food items. So that's basically a functional grouping. And then you have a more detailed functional grouping, and then even more detailed functional groups. There is a fourth one, that actually gives you the name of that species that is being consumed. So while we are, how did we sort of give the baseline? So now I'm going through how the process of providing that baseline trophic level to each of those items in the hierarchy. So we had in FishBase first, we had 2,000 records of prey that was used for the typical contribution of food items in the diet of fish. And remember that we are only looking at percent weight or percent volume. We do not look at percent occurrence of animals in the food bolus or so percent occurrence or the number of items is not useful. We use weight or volume. Sorry. And of course, we know it has to make up 100%. We also used only dominant food items, those that keep occurring in the food items table for a certain species. So we only use those that keep occurring. Anything that is rare is not used. Then we looked at the median contribution to stomach contents, of course, in percent in weight as well, which is the first dominant food item, the first item in the diet composition record, which is the dominant food item. And we have this kind of data for 2,420 records in the diets table. And then we looked at the functional groups. There should be only, there should be at least 10 records of dominant foods that occur in the diet table. Using that, we then looked at the median in percent, the minimum and the maximum. And this provided us with the baseline trophic level for each of those functional groups. So we did not make them up. We used the data that are in FishBase to make that baseline. Now we have to. This was done in 2000. So in the meantime, we have made a lot more. We have encoded a lot more, and we were thinking of doing this for 2020. However, I could not go to the Philippines because, in which case, we had to postpone it until I could go and work with the FishBase team in the Philippines. But we will then, now we will be able, with more data, we will be able to have a better, how do you say that, estimate of the baseline trophic level for each of these functional groups. So this is just an idea. Well, in FishBase we have food items and diet compositions. This provides you a way of having a trophic level estimate, or estimates of, or an indication of what the prey is of a species, if you do not have diet composition data. So trophic level is estimated using either the food items or the diet composition information. Diet composition is, of course, a more stable data set for estimating trophic level.
Deng, can I interrupt here? It's just I'm noting we have about 20 minutes left, and you still have quite a bit to cover in your presentation, and I wonder
so I can,
if you want to highlight parts of it. So
yes,
we have
I
a little
will.
bit of time left. Yeah.
So because we need to have the exercise. So I will go down here. So that's also available in SeaLifeBase. So this is the diet composition per study. Remember that there's only 10 groups, 10 items maximum that is provided in this record, and anything else that does not fit is put in others. Predator records follow the same structure and referred to as functional groups here. And then there maybe actually these are just ways of using data in FishBase. So we have done this empirical equations that are often used in testing, not testing, in vetting. So if we find a trophic level that does not fit these things, we then question the record. So this growth parameters, I already showed this to you earlier. And this is the way that we vet our maximum length thing. So this is just inside FishBase vetting data that we get from published information. Same here. And this was about if deciding whether you want to put life stages. So if there's a change in body shape, yes, of course, you might want to put a life stage and separate juveniles from adults. Length parameters, we've done that. Okay, length parameters. So this is useful if you had your length infinity in a different length. So you can, if you are using total length or whatever length type, you have to use it the same throughout your estimations. And this is what will help you get those expressed in the same length type. Right. So these are just life history correlates that were used for our max in FishBase, for which we have 1,000 species. And definitely there's graphs by family. And if you wanted to look at those, you will need to use fishbase.cn and Internet Explorer. And then you can have an idea of, if you are using something that is not from FishBase and you wanted to know whether those could be acceptable within the range of the possible values for a species, then you use the graphs to measure those points. So that's just an example for the length weight graph. If I had a separate A and B not coming from FishBase, where would that be in this graph that is for that species or for that family?